Hi everyone, welcome. Still doing grade 11, March 2022 exam paper. So let's get into it. So we've done a couple of questions already. We've done question one, in fact, the entire question one. And in this video, we'll be doing question two, the entire question two. And so let's check out our previous video. This is what we've done already. So let's jump into question two. Okay, so question two. Basically, we're doing simplification, so they want us to simplify this whole thing without using a calculator. So we're gonna dive deep into the mathematics behind certain things and how you actually see certain things and how you simplify it yourself and get to the answer. So, for example, 2.1.1, it's 9 power x plus 1 minus 6 times 3 power 2x over square root of 3 power 4x plus 1, right? So the way you would simplify this is, firstly, I'll simplify everything into its element, right? For example, you have 9. 9, I can simplify 9 into 3, right? The element of 9 will be 3. The lowest granularity of 9, we can take it down into 3. So it will be 3 power 2, right? 3 times 3 is 9. So 3 power 2 is 9. So 3 power, I can simplify 9 to 3 power 2, right? So 9 can be written as 3 power 2. Still have x plus 1. With 6 as well, I can simplify 6. 6 is 2 times 3, right? This is the elementary level of 6. So I can write that 2 times 3 and still have 3 power 2x. I can't simplify that further. And with square root of 3, square root of 3 can be written as 3 power half, right? That's square root of 3. So let's just write it this way, 3 power half. So 4x plus 1, okay? And then now from here we can now multiply the exponents, right? So you have 2 times x and 2 times 1. So you have 3 power 2x plus 2, right? 2 times x is 2x, 2 times 1 is 2. Now here, we don't want to multiply anything further because we're trying to simplify everything. So you have a compound in mathematics and you want to break this compound into its elements, right? So if 2 times 3 times with this, because we know if you have two bases that are the same, if a times a power 2, two bases that are the same, what you're going to do is you're going to add the exponent. A times a power 2 is a power 3. It's a power 1 plus 2. There's 1 here. It's that 1 over there. It's a power 3. So even in this case, we have bases are the same, so you can add the exponent. So it's 1 plus 2x. So it's going to be 3 power 1 plus 2x. 3 power 1 plus 2x, or 2x plus 1. Okay? So that's what you have. And with the exponent, we can still multiply the exponents again in this situation here. So half times 4x, half times 4x, that's 2x. So you have 3 power 2x. Half times 1, that is half. So 1 over 2 times 1 is 1 over 2. And then we can now see something. There's a pattern that we're already seeing because we're doing math, so math is always about pattern. I see 2 power x, I see 3 power 2x, I see 3 power 2x, I see 3 power 2x. So I can factor out a common factor here because there's a common pattern that we're seeing in this equation. So I can factor out that out and see what happens, right? So let's just do that. So 3 power 2x. And mathematics is about that. It's about pattern numbers, recognizing patterns, recognizing numbers, and trying to do something with these patterns and numbers. That's basically what mathematics is all about. So 3 power 2x is what we're seeing here as a common factor. So you're factoring that out. So if you factor on 3 power 2, basically what happens is you're saying 3 power 2x plus 2 divided by 3 power 2x, right? So when you factor out that, so you say divide all of this thing by 3 power 2x. So 3 power 2x plus 2 divided by 3 power 2x is 3 power 2. 3 power 2. How do we know that? Remember, if you have a power b, let me make numbers, 2 divided by a power, let's make it 2, or All right, then it's just 4 divided by a power 2, just to make our life easy. Maybe plus 2x. Okay, just to make things interesting. So to do this basis, so the the theory or the axioms around this says if bases are the same, therefore you minus the exponent if you are dividing those bases, right? So bases are the same, therefore you minus the exponent. Bases are the same, therefore you minus the exponent. If it was multiplication sign, you're gonna be adding the exponent. But if it's division sign, therefore you minus the exponent. So we're just saying 3 over this, then you minus the exponent. So in this case, it's going to be a power 4 minus 2 minus 2x, which is a power 4 minus 2, that is 2, which is negative, and plus 2x. So this is basically how you calculate this. Even with this one here, that's how we got that 3, 2. So we say 3, 2 power x plus 2, 3, 2x plus 2 divided by 3 power 2x. Again, your minus exponent is going to be 3 power 2x minus 2x minus 2. So therefore, you have, sorry, my bad. 3 power 2x plus 2 divided by 3 power 2x, which is 3 power 2x minus 2x, that's 0. So 2x plus 2 minus 2x. Therefore, this 2x and this 2 is cancelled. We end up with 3 power 2, which is what you got here. Okay, so you're doing the same thing also with this, right? 3 power 2x plus 1 divided by 3 power 2x. The 2x and 2x will cancel because 2x plus 1 minus 2x is 1, because you have 3. So you have 3 power 2x plus 1 divided by 3 power 2x. So you're dividing, bases are the same, therefore you minus the exponent. So you're going to be 3 power 2x plus 1 minus 2x, which is 3 power 1, which is just 3. Okay, so you have just 3, so it's minus 3. So in this case, you have minus 2 times 3. Right, so we're going somewhere with this, and still in your diminutive, you're factoring out 2 power x. So if you factor out 2 power x, you're gonna be left with 3 power half. Okay, and then 2 power x divided by 2 power x, that cancels, so it's 1. So you end up with numbers now. Whew. So 3 power, so you end up with numbers 2 power 3 over 3 power half. Okay, it's good, we love numbers, it's easy. Now we can do this by ourselves. 3 power 2, it's 9. 2 times 3 is 6. 3 power half is square root of 3, of course. And 9 minus 6 is 3 over square root of 3. Boom, that's your answer. You're done. So this is how you would actually do it. So marks here, I would say 4 marks. So 4 marks is firstly, yeah, actually doing these things here for 1/2 a mark, and doing that for 1/2 a mark, doing this for 1/2 a mark, give, and doing this for 1/2 a mark. So you've already 2 marks, and maybe I'll give for factoring out a mark, and so you've already 3 marks. I'll give for the answer for 3 marks, and then also having effective for 1 mark. So boom, you get your 4 marks. So yeah, so let's do 2.1.2. So again, we're doing this with factoring out or simplifying this without the use of the calculator. Okay, so from here, this is 9 by the way. So from here, again, you see the compound, these compounds, see these compound, so you break it down into its element, right? That's what you're doing, trying to simplify it into this element. Okay, first thing we know, the assumption, we know that square root of a is a power half. That we know. So we're going to be doing that. So here, square root of 4 root, us also we know square root of a times b, or rather square root of ab is equal to square root of a times square root of b. We know that. So that's what we're going to be doing. So square root of 4 x power 9 is square root of 4 times square root of x power 9. Even with square root of 16 times x power 9 is square root of 16 times square root of x power 9. Square root of x. Okay, and square root of 4 we know is 2. And we have square root of x power 9. Square root of x power 9 can be written as x power 9 power half. Remember, square root of a can be written as a power half. So square root of x power 9 can be written as x power 9 power half. Okay, and then minus square root of 16 is 4, we know that. And then square root of 9 again can be written as x power 9 power half. Square root of x, this can also be written as x power half. Okay, and then we have 2 times x. Now we can multiply the exponents. So 9 times half is 9 over 2 minus 4x. 9 times half is 9 over 2 again over x half. Now we're going somewhere with this. We can see this is the same thing, right? So these are like terms, so we can actually minimize them. So 2 minus 4, it's negative 2. So you have negative 2x power 9 over 2. Why we can do this? Because these are the like terms. It's just like terms, so we can actually minimize this. So you have x power half. By the way, you cannot do this if it was probably not like term. So if it's not like term, like let's say this was just 9 over 3, then it's not the same, so you cannot do anything. Okay, so we're doing this because we can minimize these two because they are like terms. Okay, and then from here, then we're doing what you've been doing in the previous video. We are bases are the same minus the exponent. So you have negative 2x power n minus 2 minus 1 over 2, which is negative 2x. N over 2 minus 1 over 2 is just 9 minus 1 over 2, which is negative 2x power 9 minus 1 over 2 is 8 over 2, which is negative 2x power 4. Right, so that's your answer. That's your answer. Right, we're on fire. Let's go. So let's see. We have, so I will give you marks here. So I would actually probably give you 1 mark for this, for an answer, of course. And I'll give you I want to give you 2 marks here. Not there, actually. I want to give you 2 marks. 2 marks there. And that's just simplifying. Yeah, I'll give you 1 mark here. Right, so that's basically how you get your answers. 4 marks. Right. Okay, let's do question 2. 2.2. Alright, determine the value of k for which the equation 1 over k x squared minus x plus 1, where k it's not 0, has real roots. When you talk about real roots, make it red. Real roots meaning we have a solution. So we have x is equal to some value, right? X is equal to some value, right? So for x to be equal to some value, this is a reason why I want to teach you to use a quadratic equation, because of question like this. Question like this, they test your knowledge about the quadratic equation, right? Because we have a quadratic equation here, and you can use a quadratic formula, right, to solve for x, but we don't know 1 over k. So in this case, we can play around first and rearrange this to look like a quadratic equation, so that you can use the quadratic formula. So you have x squared minus x plus 1 is equal to 1 over k, right? And then you can take that 1 over k into your left hand side, become negative 1 over k is equal to 0. And then if it's like this, then you can use a quadratic equation. So in a quadratic equation, what do we know? We know that we have the formula is x is equal to minus b. The formula is x minus b, I was thinking something, but it's fine. It's still gonna be the same thing. So minus b plus b squared minus 4ac divided by 2a. Okay. Okay. So this is a quadratic equation. So what is our a? Remember, this is our a. The coefficient of x squared is our a. So a is 1. Our b, it's -1, the coefficient of x. And then our c, this whole thing is our c. Right? So you can substitute these values. We have b with a with c. You can substitute these values to get your x. So, but we need to, there's a rule about this equation here. This rule says the square root of b squared minus 4ac, right? This, all right, not the square root, but what is inside the square root, b squared minus 4ac, can never be less than 0, because a square root of a negative number is not a real number. You're not going to get a real number. You're going to get, it's not applicable in real numbers, right? It's not applicable in real numbers. Maybe in imaginary numbers it's applicable, but in real numbers it's not applicable. So we cannot have a situation where this is less than 0. We cannot have a situation where this is less than 0. It should always be 0 or greater than. It should always be 0 or greater than 0. So it always should be positive or 0, right? It's always should be positive or 0. But in this case, we're being told that k is not 0. So it's either greater than or 0, but we are being told that k is not 0, so it should always be greater than 0. So you don't ever have a case where k is 0. Okay, so b squared minus 4ac should be equal to 0. Now, what is b? Okay, b is -1, right? From our equation, b is -1. So you have -1 squared minus 4. What is a? A is 1. What is c? C is 1 minus 1 over k. It's equal to 0. Oh, by the way, it's greater than 0. Okay, and then what is -1 squared is 1. -4 times 1, that is 4. 1 minus 1 over k. Then you can remove the bracket. So to remove bracket, this times that, right? So it's going to be 1 minus 4. -4 times -1 over k is +4 over k, greater than 0. Okay. And by the way, we are trying to solve for k here. So we need to be sort of careful on what we are doing. So we have 1 minus 4 plus 4 over k greater than 0. Oh, sorry, I can say it's 1 minus 4. So 1 minus 4 is just -3 plus 4 over k, 0. And then you can take the -3 into your right hand side. It's become positive. So you have 4 over k greater than 3. Okay, and then from here, from here, we can now cross multiply this. So we have 4 over 3 is greater than k if you cross multiply. So if you cross multiply this, because I mean, if you look at this carefully, you have 4 over k greater than 3 over 1, right? So cross multiplying meaning you say this times that. That's cross multiplying. So you have 4 times 1, which is 4, and then 3 times k, which is 3k. And again, you can now divide by 3 on both sides. So the 3 and 3 cancel. We have 4 over 3 greater than k. So that's what we have there. Okay, so k is am I missing something here? So k, am I missing something here? K is less than oh yes, k is less than 4 over 3 and k is less than 0. Okay, k is less than 4 over 3 and k is less than 0. I mean, k is greater than 0. Remember, we are being told that k is not equal to 0, and k can never be negative as well. So we have a situation where, so your answer is k is greater than 0, and k is 4 over 3. It's less than 0. So k can never also k can never be equal to 0. So that's your solution. That's your k. Your k can never be equal to 0, and your k is actually between 0 and 4 over 3. That's your answer.